Well, thank you for joining us. This is a great topic, and I'm just elated to have on board here Kate from Corning, and Frank, of which we discovered we've known for how many years now?
Well, over 20 with TVC.
Yeah, more hardware and tonnage than you can think
Absolutely.
About building networks.
We have.
And we had some great backstage discussion on a topic that's near and dear to my heart. So I did want to open it with maybe Frank saying a few words about kind of what's the framework that this discussion is going to be about.
Okay, very good. If I can have the clicker, Mark?
Sure.
So what constitutes an emergency? As you know, power outages is one of the first things you realize that creates the need and the demand to do something to respond and to quickly get the network up and running. There could be distribution and supply chain. It could be a critical supplier that has a problem with their ability to provide products to you. They can cause a problem with the network as well. The one that's near and dear to all of us that we have most experience with is natural disasters, and we'll touch on that in a little bit. Human error, cut a fiber line, that's a problem. And sometimes they're the hardest to find, and Kate will be talking about those. Malicious attacks, different types of cyber issues, and redundant link may be taken down. So maybe you think you're protected, and you find out you're really not. So UPS system failure and battery backup is the #1 cause for unplanned data center outages. And it's about 1/4 of all such events. So a lot of you that have your own data centers or may have co-location, you have to be concerned about that. That's something you should be thinking about when you're designing your network. One of the bigger ones is the natural disasters. This chart clearly shows that over the last 10, 12, 15 years, the events that are $1 billion or more in potential damages are on the increase, okay? And we've already seen that recently here in 2019. It impacted a lot of people, and we're not done yet, right? So that is definitely one, and I'll be touching on the supply chain aspect of that a little later. So cybercrime, that's on the rise, right? 20 years ago, not that big of a problem. Now it's an increasing problem at an alarming rate. When you talk about 2% from 2010, 18% in 2013, and increasing, it's something you absolutely have to be concerned about. And when you look at what it costs businesses, this is cost per second of downtime. That's staggering. And that impacts business disruption, it's lost revenue, it drives IT people crazy. It is definitely a big problem. So the obvious things about an emergency are things that cause you to stay up late at night. It's all about how you respond to that and protecting the communication network. Mark, if you can take us through that.
Yeah, sure, thank you. Thank you, and by the way, I like the way you framed that, because if we look at our networks today versus what they were 20 years ago, it's a much different expectation from the consumer as to the dependency on the applications and services that we provide today.
That's right.
Much difference. Also, the network architecture, and I'll go through that a little bit, and I think Kate's going to be able to talk to that very nicely. The dependency, especially our optical network, on sources of information and connectivity that we didn't have 20 years ago, that literally cutting an optical cable or coax cable, especially an optical cable, is relatively dangerous to the impact on our communications and welfare of our citizens. So let me just go through this. So if you look at really what the protection's all about, we're starting a campaign, and this was started around, and I like to frame this because this is terribly important. For the first time, the federal government, DHS, FEMA, of which SCTE is part of the protection program for our industry. We represent the communications interface with Department of Homeland Security and FEMA for disaster recovery. We operate and license a program within our industry called SHARES, which is a two-way radio system when all is dark, using the Department of Defense channels for our industry to communicate with DHS and FEMA to make sure we can get fuel, we can get access, we can get parts. We can very rapidly restore our network. The problem is not only the problem of destruction from hurricanes and others, but it's actually cutting cables that are, in many cases, the vast majority of the network outages, which is self-imposed unavailability for our network. So cutting or damaging a cable, network facilities, I'm going to go through what that means, but this little icon that we have, do not cut, is a big deal. It relates to power companies, Department of Public Works, contractors for clearing the right of way, and traditionally there's been a policy of do not block traffic. We need to get emergency vehicles and other vehicles into a particular area or market. There's no question about that. The problem is, where do they go without communications relative to the first responders identifying folks that are calling in on cell phones, on cable networks, and others, to include our, as an example, the other carriers are frequently within the same sheath from a optical network perspective. So when you cut a cable, frequently a lot of that communications is lost, and I'll go through some of the very explicit examples. So and this will be kind of an overview, and then I'll go through some of the specifics, that the rapid network recovery is essential. And why? Because there's some things we can't avoid. In some cases, the cables do get cut. In some cases, the cables are naturally severed through a number of different means, right? There is a lot of cable tension issues. And by the way, I know from a TVC perspective, you guys have done a good job by making sure that the strand, people don't realize there's actually more than one strand diameter and strand strength that can actually help survivability of networks in critical locations. As an example, what is I think it's 3,000 or 4,000 pounds. You can actually go significantly higher for much greater load bearing that can actually help survive cable separation during a pole line failing. So I mean, there's a lot of things you can do if you actually think about it. So, so how do we do the rapid recovery? And then we'll talk about things we can actually maybe do to not only recovery, but prevent it from happening. The E911. A lot of folks don't realize that when you dial 911, it's not only police, it's also fire, and it's also emergency services. Frequently in the 911, it's either through our telephony, it's through a cell phone, or it's through another mechanism. It could be an alternative provider. The fact is that is most likely the number one communications, initial communications to start a recovery, or at least identify that there's a perilous environment, you need to get on the list for evacuation, and then they'll prioritize it. Then the local regional alert system, which is kind of interesting because I think the cable industry actually is the greatest form of telecommunications alert with the public through the alert system. We've all heard it, 2 o'clock in the morning with a very caustic buzz, right? It wakes everybody up, you left your TV on. That is the intent of it. And the intent is to make sure that if there's an event that has a very short time interval for a response, that it's alerting as many people with the most caustic video and sound that can get people's awareness around the alert system. We are critical about how does that alert system connect? It connects to our backbone, frequently to a remote location over the Corning product to remote locations that may be not only just in a state, but in federal locations that may be thousands of miles away. So we're starting to build the portfolio of why we need to make sure we have connectivity in these networks, even in very adverse environments. Also, internet access and Wi-Fi spots. Think about, I look at the millennials. We see some data from, without mentioning the government agency, that some of the folks in urban markets and the millennials are so dependent upon their handhelds, maybe it's because some of us necessarily didn't grow up with it, that the dependency is such that in the event of a loss of power, the primary source of energy for wireless, for a lot of the communications entities, within 72 hours there may be panic. So we don't always understand that the loss of communications, the inability to restore communications, actually can drive civil unrest. And that's a major issue that isn't always spoken about, but is a major concern from a response issue. And to include, I know HHS and some others are looking at major responses that may run into millions of people if, as an example, there's single points of failure in our power grid. Single points of failure, as an example, people don't realize that GPS, in many cases, is the synchronization for most of our transport from a digital network perspective. So there's a lot of those kinds of not necessarily obvious potential root causes for significant failure. What is the duration of that failure? And the question is, if it goes beyond 72 hours, it's actually pretty dangerous. So this is a very serious story. But the internet access around weather, watching the National Hurricane Center. Here's one that popped up recently, especially for industry, CDC. People don't realize that there has been influenza impacting the workforce, to include a large number of issues that you can actually go to CDC and other websites for disaster control or disaster recovery around first aid, around managing radiological environments, all kinds of issues. As an example, Sandy here in New Orleans, people didn't realize it, that when you're recovering a facility, the material that is on the basically washed up during that flood process, in many cases was very dangerous. It was toxic, there was human waste, there was all kinds of other material, to include a lot of toxic materials that were a product of fires and other things that were taking place. So the CDC is actually a communications that is vital to recovery, but it also can be lost in the discontinuity of our networks. So internet is very important. Also, you find out you may not be able to make a phone call, but you can text. Text is determined by the first responders to be one of the most critical forms of communications when everything else is failing. It's not real time. You may not have voice communications. Voice may be in a blocking mode where it says all lines are basically utilized, and text can still work, which is terribly important. So the internet is a big piece of response communications. Cellular communications, I believe, we're about, in some markets, 2/3 of the backhaul. And I know TVC and Corning are critical to the backhaul infrastructure, because if that's severed, then there's a whole nother connectivity issue for first responders. As an example, we're working with FirstNet, which is a government-sponsored relationship with AT&T to provide first responders with connectivity on a primary basis. We're working with them. We have a lot more work to do in 2020 on how do we tie that into work that we'll be deploying in the future that will be dependent upon FirstNet. And the connectivity, which is kind of interesting, because we've discovered that FirstNet and other government agencies are connected over Metro E on our network. That the first call I think we got about 2 years ago about what about critical infrastructure. I know you're an entertainment network now. We depend upon you guys. All of a sudden, last year's hurricanes, it was like we desperately need you to figure out how to stop cutting cables, because their own facilities now were on our Metro E facilities. I'm a member of the Long Beach Township, Long Beach Planning Commission for the police department, and they've moved all of their radio communications connectivity, all of their search engines for criminal investigative work. Everything now is on Metro E. So you think about, we don't always think about who we're serving, but some of these folks are absolutely dependent upon, to include all the recovery communications, coordinations with the county, the state, National Guard, all the military is over our Metro E networks. So the reliability of these networks are critical. But back to the cellular, about 2/3 of some of these markets are our backhaul. So somebody said to me, well, gee, are we going to lose that with 5G and the rollout of 5G? No, actually, I think we're going to be providing a lot of their backhaul, because the number of sites they need, in most cases, do not have access back to their central aggregation points or switching. And also remote health monitoring. If were any of the folks here during opening session and are announcing some of the things with Dean Kamen about telemedicine, autonomous vehicles, SCTE will be taking the lead on defining how these applications are delivered over our networks. And what's critical is the work that TVC and Corning are doing to help us deliver the networks, to include keeping material on hand for rapid shipping for recovery and those kinds of things. But if you notice, Dean Kamen was talking about the autonomous vehicles and the work that he's doing. Today, the FedEx bot is piloting in 3 of our markets. Telemedicine, the first homegrown response to the kind of outpatient medicine, and this was outpatient care, was initiated in New York this past month, and I think it'll be operating independently outside of a hospital this coming week or 2. So, and this is home dialysis. So the whole life experience around, let's call it aging in place, smart cities, telemedicine at home, looking at how we live and how we age and the quality of life in that process is now becoming much more dependent upon how we deliver and operate our systems in a very responsible way supporting these. And also let's talk about 10G, which addresses these. 10G is not just about bandwidth, and if anything, what TVC and Corning are doing, and especially on the optical side, the dependency on the support for the backbone, and let's use a couple of examples. We look at 10G, which is 10 gigabits, relative to 5G, which is 5th generation, and really not a definition of the bandwidth. If we look at holographic video, holographic is basically light fields that are showing a 3-dimensional view of a graphic, right? And some of the graphics are pretty interesting because one of them potentially is an aged family member who has passed that you've taken a 360 view of that individual, can be brought back to life using artificial intelligence from a graphics perspective. So you'll be seeing these in the, I think it's called the near future by Cable Labs. SCTE's job is actually bring these to life, bring 10G to life. We're going to be demonstrating probably some of these next year. But the bandwidth is 1 gigabit full duplex just to perform one connected interface for that one point-to-point service. So you look at the bandwidth requirements, the number of optical channels required, and the amount of survivability and continuity assurance is significant, especially when they're telemedicine, a lot of very dependent applications are going to be taking place. Now, there's a lot of outpatient care to include microsurgery, a lot of other work that's going to be be done in the home moving forward, and we want to participate. So literally, we're starting with a white clean paper and a pencil to launch that this year and being able to define it for our cable industry and those applications coming up. So I know that's a lot for one slide, right? So if we go to the next slide, I just want to make sure, and I'm going to ask that this deck is available to all of you, that every one of you in the audience go to the field, make sure your power company, Department of Public Works, anybody that has the potential of a hazardous response is aware that they move the cable aside, do not cut the cable, and be very careful, even if you have to take a few minutes, because if you cut the cable prematurely, because you're saying you need to clear the road, the response may be the people that you want to save by those response vehicles may not have anybody to communicate with because you basically cut the communications that are vital services to the folks that you're trying to help and respond to. So we clearly have the 911 component of it. We clearly have the emergency alert, and there's a lot more detail you'll be able to get from the website. The wireless internet disruption is terribly important. Clearly the cell site activity, and also to make sure, and this is going to be growing very rapidly, remote health monitoring. My wife today has a pacemaker that's Wi-Fi connected to our Wi-Fi system in the house, which also makes you think about IoT, and IoT having wireless repeaters and other things in the home to be able to secure continuity, even if you have power outage on your main power in the house. There is some discussion today about 72 hours of backup on healthcare devices. So in summary, it's terribly important to make sure the telco, power, government, and cable is at the table, and that we are part of that discussion, and that I think we've got great partners within TVC and great partners at Corning to make sure that we can respond as quickly as possible. So thank you, and I'd like to pass it on to the folks that are actually doing it.
Thank you, Mark. On to you, Kate.
Thank you, Mark. Thank you. Can you hear me all right? Thank you. Kate with Corning, and thank you for the wonderful lead in to this topic. And what I'd like to do is begin to share, number one, a high-level view of what is the role of infrastructure transformation in this process of achieving resiliency and emergency restoration, and then move into a fairly detailed view of how can we locate issues, troubleshoot issues, and be prepared to be resilient to those issues. So we'll bring it down to a really tangible level here at the end. But before doing that, what I'd like to offer is an architectural perspective on the role of transformation in moving toward a more resilient network over time. So traditionally, if you look at the cable TV network, much of it has been an active plant, meaning powered plant. You have hundreds of thousands of active nodes out there in the plant drawing power, and that's the present architecture today that most operators are using. And what we're seeing over time is moves toward a more passive plant, so a plant that has more fiber in it. We're still having nodes deeper into that network, closer to the residences and businesses, but over time the trend has been the technologies used in the core of the network are moving closer to the edge, and that's bringing more fiber out into the edge. So this is an immense opportunity because fiber in its nature is truly passive. It is inert in essence. It doesn't draw power, and it's not dependent upon active nodes in the field for that network to be operational. As you move toward an end state where you're bringing a fiber from a head end all the way to a subscriber, be it a residence or a business, that is a move toward an ultimately truly passive plant where a source of power at the head end and a source of power at the home gives you all you need for communications, provided there's continuity of the glass, right? The plant does not draw power. And so in the move to that investment, in moving in that direction, I would offer there's a few things that could also be thought of in that process. So here recently, smart cities is a very interesting topic, and one of the things that I've been studying is well, what is the role of the network in enabling smart cities to become a very real thing for our folks? And in doing that, I've had the pleasure to speak on a number of panels for either actually tomorrow for the Smart Cities Council. We're doing a whole panel on the role of smart cities in this industry too, and also a smart and resilient cities based out of some cities that have been impacted by hurricanes. And so in performing some of these panels and analyses, there's an opportunity to apply investment as you're moving toward a more passive plant, to also achieve a more resilient network upon which a smart city could come to pass, and fiber optic sensing. This is a technology that could enable us to perceive what is going on in an environment in a purely passive way, meaning not dependent upon power, understand when something is submerged, understand when a building has been damaged, to perceive that there's been a traffic accident. All of this over plant that presumably, we're moving toward making these investments anyways. And so I'd offer that considering the role of a passive optical architecture through the lens of being very resilient and not dependent upon power, with the exception of the source and these are instances where there's probably immense opportunity to support resiliency above just the network level. So that said, where we talk about passive optical plant being very resilient, and my word, inert. So it's you either have continuity or you don't, right? So you're either going to have problems where there's a break in optical continuity that's very easy to locate. So now we're getting down into some of the very tangible things about restoration and maintaining a plant. So these could be instances where something has physically damaged something you can see. A pedestal gets knocked down. A cabinet at an intersection gets taken out. People cut their cable, right? This happens every day, usually at the edge of the network, but it happens quite often. There are instances where people will intentionally cut a mainline trunk just to disrupt, as you were describing, you can get civil unrest from these types of activities. So there are people that are intentionally doing this. Natural disasters, provided they're localized in some form, or at least you can observe what the issue is. These things are usually easy to spot, and you can take action to address them. In other instances, you can have discontinuity in the optical plant that's much harder to recognize. These could be very small component failures. Rare, but it can happen. You can simply have, critters digging in and cutting into your plant. Squirrels are fairly famous for that. Gunshots, another one. You think that doesn't happen, but it actually does quite a lot. Buckshot can actually penetrate a cable, and that's really hard to locate. So that conduit collapses, and there are instances where you can't visually see what's going on in your plant, and you do have an instance of discontinuity. So knowing how to troubleshoot and seek those things out, one recommendation is know exactly your line diagram of the network that you're trying to troubleshoot. Active plant, passive plant, what's the type of disruption that you're looking for, and use the troubleshooting tools available to you in terms of an OTDR for the optical plant to measure the distance of where that discontinuity exists. The same thing in an active plant, but you have to track down the instance of discontinuity and address that with kits to address how you're going to put that plant back online. So a rule of thumb, if they're components, they can usually be swapped out fairly easily. Having these on hand, right? These are items that can be kitted. We'll talk about how to have continuity of supply in an instance where you're putting a plant back online. But these are all components that I'd offer if you had on hand, you can swap in and out of a network and maintain continuity in this way. Another perspective on this is as the plant moves more toward the passive optical realm, and as you're looking at ways that your network is supporting a city infrastructure that's reliant upon continuity, understand that connectivity can help in an emergency restoration environment because it's a quick swap in and out, right? So the role of connectivity brings efficient use of passive plant all the way to the edge. And then you can also apply all of those same types of cable that you're very familiar with over the years, splice these things in and out if connectivity isn't the easiest path forward. Yep. So the proposal here is a handful of different kits. You look at the HFC perspective. As you're migrating closer and closer to fiber, you're going to start looking at the fiber to the X perspective. What are the types of products you need to keep on hand so that when you have identified an issue in the plant, you have located that point of discontinuity, you have on hand what's needed to put that back online in as short amount of time possible. We talked about the types of emergency services that are dependent upon the networks that we operate today, and having a plan to get them back online as quickly as possible means having a plan to do exactly that. And these are proposals for the types of products to keep on hand to accomplish that goal. All right. And so I'll
Very
offer
good.
this
It's excellent.
Thank you, Kate.
and wrap us up with supply chain.
So I'll try to bring this home. We don't have a whole lot of time left, but
Please complete your thoughts. It's very important.
very good.
Very.
So the supply chain support is obviously critical. To all of you as operators and to your end customers and getting your network back up, you want to minimize your downtime. I'm sure you have SLAs that you have that you're at risk from a financial perspective to make sure that you're able to keep that up and running as you need to. What we do from a supply chain standpoint, there's a couple ways to look at this. One, being very proactive and preparing in advance is critical to being able to maintain and bring your network back online. So you can start in advance by saying, before an event takes place, predicting for a hurricane season or for ice and snow in the wintertime, what type of supply would you need on hand or have a supply chain partner hold for you to make sure it's going to be there when you need it? And some of this is predictable, right? Some of it aerial hardware, things like that, fiber cable from Corning, those types of things that they're going to be the first thing you have to get in there and do. You can prepare for that in advance and work with your supply chain partner to try to put those things in place. There's also the situation without advance notice that happen instantaneously, cut fiber, those types of things, like at the end of the network at the edge. Those are things that make sure that you have a partner, that you have warehouses or that you have stocking capabilities and things that can get those materials to you within a day or even same day in some cases, depending how they run their logistics. It's critical to understand that up front. So when you need to make that phone call, you're going to get instant response from someone and not have to wait for materials. So look at local, regional, national providers. Look at people that can support how your network is laid out across the U.S. and how those people are best positioned to support you. Cross-reference items for some common items. A supply chain emergency plan. Ask your supply chain provider, do they have an emergency plan? Do they have a step-by-step and contacts that you can use and know who to call late night, weekends, 24/7 response when these things typically happen? You want to make sure someone's there to back you up. This is interesting too. This is on the utility side. We use actually prepackaged storm kits. So if you have a base camp you set up in a natural disaster type of situation, it could be a shopping mall parking lot, it could be a Walmart parking lot, that they stage crews and trucks in these storm kits so they can go out on site to project spots as quickly as possible in an organized manner to get the network up and running, right? So the same thing is for cable operators as well. So you get the utility up and running. Right behind that, you want to get the cable network up and running. And I mentioned about personnel in place, right? A field commander, inside sales, customer support, operations people, and the ability for us to provide people on site where the action's taking place to help you manage through that so you can actually have your crews doing the work and making all that happen. And we actually have a minute and a half left.
Oh. I have a couple thoughts, if you're okay.
Yes, sir.
This is a great example, though, of, from my experience, and I've run some very complex, very large networks. The preparedness is so critical that you can't be taken for granted, because the problem is, even with a minimal level of preparedness, I've actually opened up hurricane kits and found out somebody used the splices, somebody used the equipment, and pieces are missing.
Right.
So the preparedness is not just assume that you have everything. They have it available. You need to make sure that they are prepared to be able to do it, because they've done it before
Right.
With me, and we know personally.
That's right.
That the preparedness is critical. But then on the other side, I want to make sure that we need to do whatever we can to mitigate the failure of our network through human behavior, cable cutting, whatever we can do. Accidents will occur. Some cutting and severing of our cable will occur, but we have to minimize it, because the response time is part of the problem. Getting to the site, clearing the site, being able to splice optical networks is not a trivial task. I mean, it's important, and that it's done right. By the way, it's much faster than it was when a number of years ago with the mechanical splices, right?
That's right.
But I think that you've done a great job in being able to package this in a way that can be very, very rapid response. But what's important is we really take it proactively. Some of the applications we're going to be delivering are dependent on us doing this, and as a community. We're no longer an entertainment service. We are a hardcore communications network. We're life-saving and response, and our ability to sustain an operating network is going to be critical to the competitive environment. So I'm very grateful for TVC and Corning to support this. You guys have any comment?
I do not. That is probably the best conclusion we could have delivered. So thank you, Mark.
Thank you for that.
And thank you, Kate. Thank you very much. Ladies and gentlemen, please, a hand for some folks who really know what they're doing.
Thank you. Okay.
Thank you, Mark. Thank Kate, Frank. Great information. Scary, but great. We're going to take a short break and reconvene at 3 o'clock. I'm going to change the tune a bit and talk about advertising, where Canoe, NCC Experience, Blockgraph,